Hi everybody and welcome. Today's lesson is going to continue working with radicals. So last time around we were looking just at radicals and defining them and simplifying them. Today we're going to start looking at some operations with them. So we'll see things like addition and subtraction and multiplication, basically getting comfortable working with more than one radical at a time. So the first thing that we're going to jump into is adding radicals. So the idea for this is that we can add radicals if their radicands match exactly. So radicand is just a really fancy word for what's inside of the square root. So all that this is saying is that if we have something that has the same square root term, so the radicand is right here. So if those radicands are the same, then we're just allowed to add whatever's in front. So it's kind of the same idea as if we had 2x plus 7x. Because the variable is the same, these would add up to be 9x. So in this case, the radicand is the same, so we also add them up, and it is 9 root 5. Just like adding variables, we don't change the radicand, it just stays as the same root that we have there. So in order to do some of the adding and combining these terms, we have to make sure as we're working through that we are doing the operation to make sure that everything is simplified first. So the big idea here, and I'm actually going to flip down to the examples on the back here, is we have to make sure that everything is simplified before we go ahead and we start adding. So in our first example, if we take a look, we actually have the same radicand already. So if we look through this, all we need to do here is just add the 5 and the 2, and we keep the radicand the same. At this point, if we look at 15, it can only break down into 5 and 3. So there's nothing that we can take out of it. So basically, there's nothing more we can do. 7 root 15 is our final answer. A second thing to note with these radicands is we also have to make sure that our index, so this little guy right here, the 3, that does have to be the same on both roots. So over here, when we were adding the 15s, we saw that it was a square root because there was nothing there. So over here, it's a match because they're both cube roots, or they're both to the third power. So otherwise, our radicand is the same, so we can just do 9 minus 15. So 9 minus 15 is negative 6, and we keep it cube root of 2y. Now, the challenging aspect of this is introduced when we get to things that are a little bit more complex. So maybe they don't match up. So we'll take root 50 and root 18 as an example here. So if we break down the root 50, I'm going to have you actually pause now and say, what is the root of 50 when we break it down? And we should get for this a pair of 5s that come out, and then the 2 stays in. So the 5 comes out, and then the 2 stays in. So now let's break down the root of 18, and I'll have you do this as well. So breaking down 18, we'll get 2 times 9, break down the 9 into 3 times 3. So a pair of 3s come out, and then the 2 stays in. So in this example, bring down our minus sign. The 2 stays in, the 3 goes out. So now we're left with a simplified question, and once it's simplified, we have the green go-ahead because our radicands are the same. So 5 minus 3 in the front just gets us an answer of 2, and then we keep that green radicand the same, and that allows us to do our addition, or in this case, actually subtraction. So the same thing goes for more complex examples, and there's a whole bunch of these examples on the page in terms of if you have multiple roots, you have to make sure that you're fully simplifying them and fully breaking them down before you start doing anything along the lines of addition or combining them in any sort of way. So I'm going to give us one more chance here. Let's do this practice problem and see, when we break this down, are we able to simplify, and what does it look like when it is simplified? All right, so if we take a look at this one, 5 times 4 is 20, breaks down to 2 and 2, and then the x is still just there. So the only thing that gets to leave are these 2's. 5x stays on the inside. So there's our first simplification. Next, we look at 16, which is 4 times 4. So we can bring down our negative sign, bring down our 6. The 4 times 4 goes out nice and evenly. And in this case, the x is all by itself, so it stays on the inside there. Next, we have 45, so we have 9 times 5. 9 is 3 and 3, and then we still have our x. So we have 2 3s, so those come out. And then the 5x stays on the inside. So if we look at this, simplifying it now, so 2 root 5x minus 6 times 4 gets us 24 root x plus 3 times the root of 5x. We can only add the like terms that we have in this case. So like terms here are 5x and 5x. So we can combine 2 and 3 to get 5 root 5x, and then minus 24 root x, because root x and root 5x are different. They're not allowed to go together. So that's the basic gist of adding and subtracting with what we have here. So now we're going to go to our next definition, which is the product property. So I don't know how these got out of order, so I'm sorry for the backwards definitions here, but product property is the next skill. And the product property tells us that the root of a product equals the root of each of its factors multiplied. So what this is saying is the way that we're doing our factorization is basically summarized by the product property. So if we have the square root of 15, we can also separate the square root of 15 into the square root of 5 times the square root of 3. So we normally were breaking it down like this and looking to take something out of it, but we don't always need to take something out of it. Sometimes if we just want to break it into 2 different pieces, that's allowed. But the power of this is actually that it goes both ways. So the root 15 is root 5 times root 3. Root 5 times root 3 is also the root of 15. So if you see something like this, if you had root 7 times root 2, you're actually allowed to simplify that into one root by just multiplying what's on the inside and keeping it on the inside. So in this case, 14 works. The only rule that we have to make sure that we're following is we have to make sure that our indices are the same. So for all of these, they're just square roots. There's nothing written there. But if we had something like this, for example, root 7 times the cube root of 2, we wouldn't be able to multiply because we don't have a match. This does not match this, so therefore our final answer is just rewriting it because there's nothing more that we can do to simplify. So when we start to look at our examples here, all that we're doing is just looking for things that we can multiply to simplify into a single square root. So if we have root 3 times root 5, in this case we're just looking at the square root of 15. Or root 6 times root 21, we would just be looking at the square root of 126. So things like that basically are what we are looking to move forward and to combine into a single root. Now, sometimes what happens when we have these roots that we break down is, on occasion, they actually can be further simplified. So the easiest way to do that and the best way to check is before you do the multiplication of what's inside, actually break down our factors here. So 6 is 3 times 2, and then 21 is 7 times 3. So in this case, if we have 2 of the same thing, because they're being multiplied, even though they're not in the same root, we can actually take the 3 out. So the 3 can go on the outside, and then what's left on the inside of the root is the 2 and the 7. So in this case, we can have 3 times the square root of 14. That's the easiest way. That'll save you the most amount of time because once we multiply 6 times 21, it's a lot harder to break down 126, and it would take a little bit more time. So if we did that, for example, it would be like, okay, 63 times 2, and then we would do 21 times 3, and then we're breaking down 21 into 7 times 3, and we'd arrive at the same answer. So we'd still be able to take those 3's out, and we would still have 7 times 2 on the inside. So it would still be 3 root 14. It's just a bigger number to work with. So save yourself a little bit of time. Before you do the multiplication, you can break down the individual factors that you have. So give that an attempt here. See if you can solve this one and see what answer that gives you when you do it. All right, so looking in this case, before we start our multiplication process, we'll just break down our numbers. So 4 times 2, 4 is 2 times 2, and then 6 is 3 times 2. And then for this x, we have 1, 2, 3. And then for this x, we have 1. So we have a pair of 2's. Oh, not that big. We also have a second pair of 2's. So coming out of our root here, we have our first 2, we have our second 2, and we got to look at our x's now. So there's our first pair of x's, and then our second pair of x's. So first x, second x. And then the last piece we have to look, is there anything left on the inside? So it looks like at the end of our branches, taken care of, taken care of, taken care of. All these are taken care of, taken care of, taken care of. So this guy is left alone. So that stays inside of the house, the square root of 3. Now remember, we don't consider that this 4 is left alone because it's been broken down. So anything that's broken down is disqualified. It's not left alone. So that is the reason why, because the 3 here is not broken down. That's why it stays inside of the house. So now we can do the multiplication, the 2 times 2, x times x. And then we have the square root of 3 as our fully simplified final answer. So a lot of working with what we were doing earlier this week in terms of breaking down roots and simplifying, just making it a couple more steps when we introduce a couple more terms into what we're doing with our notes here. So that's the overall gist for what we're doing today. As always, if you got questions, let me know. But thanks for your hard work watching the video, and excited to review these skills with you. And definitely don't